Okay, so in this video, I would walk you through the similarities between the confidence interval and hypothesis testing. Also, we'll talk about factors that affect confidence intervals. Okay, so the similarities between the confidence interval and also hypothesis testing. So, confidence intervals deal with estimation. So, the key thing here is that we are estimating. That's what this confidence interval deals with. Estimation. While in hypothesis testing, we're comparing groups or we're comparing the sample mean to the population mean to see if they are significantly different. So we saw those when we covered hypothesis testing a couple of weeks ago. So remember, in confidence interval, we're looking for plausible values for our population, right? So if our null value is contained in the confidence interval, that means our null value is a plausible value. So what this is just saying is assuming our null value, let's say for example our null value here is 15, right? And you compute your confidence interval, and confidence interval is between 11 and 17. This is your confidence interval. So remember, the confidence interval is a range of plausible values for the population parameter. So let's read this again. If our null value is contained in our confidence interval, that means our null value is a plausible value. And in this case, 15 is in that interval. 15 is contained in this interval, right? That means 15 could be a plausible value. Hence, we would fail to reject the null hypothesis because the null value is in that interval. But let's say if our hypothesis were 15 again, but our interval, let's say it goes between 17 and 19, then we would we would reject the null here. So if our null value is not contained in the confidence interval, that means our null value is not a plausible values. Then in this case we would reject the null hypothesis. I'll show you a better example in the next slide. Okay. So in the previous example, we talked about a flip-flop example with males and female, the number of flip-flops that they have. So if we were to conduct a hypothesis testing on the flip-flop example, an alternative hypothesis would be that the females and the males have equal number of flip-flops, or that they don't have equal number of flip-flops. And remember, our null hypothesis could also be written as mu f minus mu m equal to 0, because if these two values are equal, then of course the difference between them would be 0. So our null value would be 0, right? So a null can also be written as there's no difference in the true mean number of flip-flops between females and the male ESRM nursing students. And the confidence interval we computed earlier for this scenario was 2.30 and 5.06. Right, so this is our range of plausible values for the population parameter. And our population parameter in this scenario is the difference between the male and the female, the number of flip-flops that they have. So the confidence interval does not contain 0. Remember, 0 is our null value here, which means the null, which is the null value, that's 0. So we would reject the null hypothesis because 0 is not in our interval. So whenever I could give you a confidence interval and ask you what kind of decision you would make based on that confidence interval, if assuming you know what the null value is. So if the null value is not in this interval, then the null is not a plausible values. You would go ahead to reject the null hypothesis. Okay. Now let's talk through what affects the confidence interval or the width of a confidence interval. So, so the confidence levels it's like we said earlier in the first video, I mentioned that as the confidence level increases, the width of the confidence interval should also increase, and that's what this is saying. So as the confidence level increases, the width of the confidence interval would also increase. So if we change the confidence level, let's assume we construct a confidence interval with 80% confidence level, and we now recompute that confidence interval with 95% confidence level, then of course the width of your confidence interval would be wider. So changing the confidence level from 80 to 95% would make the width of the confidence interval wider. Remember, the larger the confidence level, the larger your critical value, which affects that width of the confidence interval. Okay. So changing the confidence level from say 99% to 90 would make the width narrower. So it will make it smaller. So the larger the confidence level, the larger the weight of the confidence interval. Okay. So finally, sample sizes are also it also plays a significant role when it comes to the width of the confidence interval. So the width of the confidence interval is smaller when the sample size gets larger. So larger sample sizes makes the width of the confidence interval smaller. This is because larger sample size gives us more precision about our estimates. So the more information we have, the smaller the standard deviation, because hey, we have better precision, and our variability will be smaller, which leads to a smaller width in our confidence interval. So this is just saying changing the sample size from 100 to 200 will make the width of the confidence interval narrower. So if your sample size goes up, you have less variability. Of course, the confidence interval will be narrower. And this makes sense because remember, the goal is to estimate a plausible value for our population. So the more information you have, the better you come at narrowing down to what the true population parameter is, right? But changing the so this should say changing the sample size. That's what copy and paste does. So changing the sample size from 450 to 180 will make the width of the confidence interval wider, because of course we have less information here with 180 compared to 450. So if the sample size gets smaller, the width of the confidence interval will get wider. If the sample size gets larger, the width of the confidence interval will get narrower because we have more information about our statistic. Okay, so that's the end of the video. I encourage you to complete your worksheet. I would have a sample worksheet online, so there'll be a note for you to complete, as well a post video quiz online which I would put up soon. So talk to you soon. Bye bye.